Good evening, everyone. Welcome to the Integral of the Day. Today is 17th of July, 2025. Let's get straight into this one. It's a quick one. And it involves some King's Rule. So, for those of you that don't know about King's Rule, also, by the way, I advise, do pause the video and try out for yourself before listening. It's quite a nice one to discover. So, if you discover it yourself, it'll be better than me talking you through it, right? So definitely have a go before moving forward with this. Okay. So obviously the King's Rule, although I did actually give the clue at the beginning of the video, that's fine. King's Rule says the following. Okay, so I'm just going to basically assume that you know this and just recap it here without formally justifying it. But you can definitely do that without too much trouble. So, what's the King's Rule? Well, the King's Rule says that the integral from a to b of f of x dx is just going to be, actually let me also just zoom out on sort of this, so that, I don't have to keep moving it around. So the King's Rule says that the integral from a to b of f of x dx is equal to the integral from a to b of f, right? And so I think instead of doing f like that, I should do my f's like this. It's sort of fancy. F of x dx equals the integral from a to b of f of a plus b minus x dx. So you might think, okay, fine, and I would definitely recommend you justify that yourself if you don't believe me, because that's what good mathematicians do, I guess. But I'm going to use that, right, in my explanation of how to solve today's integral. So let's think about this. So I have the integral. Sorry, my computer's acting up. So I have the integral from 0 to 1 of f of x dx, right? Where f of x is equal to x divided by x plus, in brackets, x minus x squared to the power of x, which is actually equal to the following. So x divided by x plus x, so this is still in brackets, x times 1 minus x, all to the power of x, which is also equal to x divided by x plus x to the x times 1 minus x to the x. So now I can divide top and bottom by x, right? Because if I just bring out a common factor of x, this is just the same thing as x divided by x times 1 plus x to the x minus 1 multiplied by 1 minus x to the x. So I can do that. I kind of want to make this neater, so I'm going to try and use like straight lines instead of wonky ones, but yeah, I'll fix that everywhere else. Sorry guys, give me 2 seconds here. A little bit of a perfectionist here from me, but it's nice to be neat, even when you're doing maths. Okay. So yeah, these are all just me simplifying the fraction, right? So it shouldn't be anything too tricky. I haven't even used the King's Rule yet, right? So all of that is effectively equal to, if we just divide top and bottom by x, you just get 1, and then sort of your fraction. So 1 divided by 1 plus x to the power of x minus 1 multiplied by 1 minus x to the power of x. I think what immediately strikes me about this function is sort of what's going on here, right? I mean, it's really the main attraction. But there's something interesting about it, right? Kind of this x is sort of here. It's sort of something that I'm raising to the power of something. but then I'm moving it up to the power in the other term I'm multiplying that by. So I have x to the power of something, and then times something to the power of x. So the position of the x is swapping, which is interesting. Not only that though, but also I have my x minus 1 here, and my 1 minus x here. So they're flipping, right? So that's sort of literally multiplied by minus 1, right? X minus 1 times minus 1 is just 1 minus x. And it's sort of swapping positions as well. So I might want to think about that. And that's why this problem, that's actually what makes this problem good for King's rule, is that sort of symmetry. So it's good to notice patterns like that. And so now let's just apply the King's rule. So this is obviously going to be equal to the integral by the King's rule of f of 1 minus x, right? 0 plus 1 minus x dx, right? So if I just replace my x in here with a 1 minus x, what do I get? So obviously f of 1 minus x is equal to 1 divided by 1 plus, so we have 1 minus x to the power of, so 1 minus x minus 1 is just going to be, so we're going to have 1 minus x 1 minus x minus 1. So that just gives minus x, right? So we just have 1 minus x to the power of minus x multiplied by 1 minus x, that's just x, to the power of 1 minus x. So, okay. Well, I noticed that this sort of 1 minus x to the power of minus x is almost identical to 1 minus x to the power of x. In fact, it's 1 over that, right? And also this, x to the power of 1 minus x, is almost identical to x to the power of x minus 1, but it's 1 over that again. So I guess what I noticed that this is just equal to 1 divided by 1 plus 1 over what we had before, right? So that's going to be x to the power of x minus 1 multiplied by 1 minus x to the power of x. So I can multiply top and bottom by that. Sorry, my ears are moving off here. So multiply top and bottom by x to the power of x minus 1 multiplied by 1 minus x to the power of x. X to the power of x minus 1 times 1 minus x to the power of x. And let's see what I get. So I'm going to get the following. So that's just equivalent to f of, so this is all still just me rewriting f of 1 minus x, right? I haven't really done any integration here. I'm just doing some algebra, kind of. Well, yeah, pretty much, right? Just algebra. So just x to the power of x minus 1 multiplied by 1 minus x to the power of x, and then divided by the same thing plus 1. So divided by 1 plus x to the power of x minus 1 and 1 minus x to the power of x, right? So I guess what do we notice about the following? So what do we notice about the integral from 0 to 1 of f of x dx plus the integral from 0 to 1 of f of 1 minus x dx, right? Because these two things are the same. So this is just going to be equal to 2 times the integral from 0 to 1 of f of x dx. And this is what we want to, we want this, right? So if we can figure out what this is, we can just divide it by 2, right? And get our answer. Well, this thing up here, since we have the same bounds of integration, we can combine that into one integral. So that's just going to be equal to the integral from 0 to 1 of f of x add f of 1 minus x, all with respect to x. And then we do that divided by 2. Right? And if I look back at my functions, so f of 1 minus x is just x to the power, let me just zoom out here, f of 1 minus x is x to the power of x minus 1 times 1 minus x to the power of x all over 1 plus x to the x minus 1 times 1 minus x to the x. And f of x is just 1 over 1 plus x to the x minus 1 times 1 minus x to the x. So when I add those two things, what I actually end up getting, so notice that f of x add f of 1 minus x is just going to be equal to 1 plus x to the x minus 1 multiplied by 1 minus x to the power of x, all divided by 1 plus x to the power of x minus 1 times 1 minus x to the x, right? Because those denominators are the same. F of x and f of 1 minus x are the same denominator. So I can just add those numerators, right? So 2/5 plus 3/5 is equal to 5/5, or 1. 2/6 plus 3/6 is 5/6, right? Since the denominators are the same, I can just add those numerators. So this is what I get, right? You can verify it just by checking. And this is just equal to 1. So f of x plus f of 1 minus x is actually just 1. So this integral that I need to figure out is just the integral from 0 to 1 of 1 dx divided by 2. Which is literally just, so if we just do this, it's going to be x from 0 to 1, which, I mean, you can just kind of do in your head, right? It's going to be 1 minus 0, so just 1. I didn't even need to write out that would be x. I mean, typically, if you're doing an integration, you kind of just see that, right? The integral of 1 dx from 0 to a is just a all the time, right? That should kind of be something you can just do in your head and see, really. You can appreciate that, right? It's not too difficult. You just see it's x, and you just say a minus 0, right? It's always going to be that. So this is just going to be 1. So what I end up getting is just 1 over 2. And that's it. That's the answer, 1 over 2. What a nice answer, to be honest with you, for such a complex integral. That is a pretty nice answer. So, cool.